What I want to talk about is, Paul referred to stealth networking. I'm Ed Kohler. I'm a director within the Core Systems Engineering Group. And one of the areas I do handle, and I have a very decent background, and perhaps it could even be determined as a hobby for me, is security. And it happens to be a fascinating point for me.
He has a sick mind.
Yeah, I am a sick puppy. There's no doubt about that. So really what I want to talk about, while we're focused on PCI compliance, I want to emphasize the fact that stealth networking can be used for various uses, such as protecting a video surveillance environment. But the reality of it is that we've got a lot going on in the industry of virtualization of the environment. We have cloud, everyone's talking about the cloud, even people are talking about PCI compliant cloud, although version 3.0 is bringing a lot of requirements to those providers. We also have software-defined networking, and quite frankly, many security and risk analysts are getting a little worried that there are holes that are being developed in the environments and people are not aware of them. There have been some recent events that have occurred with penetration into power grids, penetration into retail environments that were based on the assumption that the network segmentation was done properly. The difficulty is that many of these technologies, particularly the legacy technologies, in order to provide this services separation are very complex, and it's very easy to lose a hole or to create a hole. So one of the things we want to emphasize is the use not only in PCI compliance, but also in HIPAA, also process flow control, control of SCADA. I don't know if anyone knows what SCADA is. Security control and data acquisition, used to control power grids, subways, things of that nature. Many transit authorities have selected SPB, many accounts for this security rationale. And then, of course, the locking down of the video surveillance environment. Now, the definition of a stealth network is rather simple. It's really a network that has no ingress or egress out of it. There's no way in, there's no way out. It's invisible, it's dark, it has no methodology for IP scanning. So there's no topology investigation that can be done against the network. It's based exclusively on circuit-based services, and those circuits are ISIDs that are based on 802.1 AQ RFC 6329 Avaya Fabric Connect. So because it's based on ISIDs, I want to emphasize this is not like an MPLS IPVPN environment. It is not like your normal VRF strings that we would do with something like VRF Lite. Stealth networks are private dark networks that are based on these stateful circuit constructs, the same circuits that you saw for multicast. That's what we base these stealth networks on. They come in two flavors. A layer 2 stealth network is simply a layer 2 domain, an L2 VSN, where we just simply did not give IP addresses to the VLANs. How many technologies do you have where you can get enhanced security with less command line activity? That's a freebie. So that's one version, and it's very useful for SCADA. Many transit authorities are creating L2 VSNs, stringing them along the railways, and then they run the SCADA protocol very safely, knowing that there's no IP ingress or egress out of that environment. Another version is the L3 stealth, which is really a true layer 3 environment that's based on VRF technology, and we'll talk about that. Now, I want to talk a little bit about PCI and a little bit about some concepts of identity. Between 2004 and 2006, I was in Geneva, Switzerland with the ITU-T as a subject matter expert for digital identity for study groups 13 and 17. I wrote what was then interpreted as a groundbreaking, I think you remember it, Shmulik, where I talked about composite user IDs. And back in 2004, think about it, how many devices did we all have?
Less.
One. And so when we talked about composite user IDs, it was fairly forward thinking because we realized at that point in time that people will be, because remember, this is for the next generation network infrastructure, where we're talking about long-term evolution. And we realized that people are going to have pads, people are going to have phones, people are going to have PCs, and they're all different personifications of an individual. The composite of an individual is the device you have, the time of day, perhaps your location, and perhaps even the application you want to bring up. And this is an important part of it. And Identity Engines is very much built around this composite instance. So what I did for you is I kind of highlighted the PCI DSS requirements in 12, the 12 major components, and we highlighted in red, or pink, sorry about the restoration of the color, where Identity Engines provides a solid role, and then in italics we provide a highlight of where we can actually enhance the capability of the customer to prove compliance. Another area that we provide is the ability to have the PCI standards Reflected and Treat Identity Engines and Fabric Connect as a segmentation enforcement tool provide validation audits against the policy mandate that has been developed by the cardholder data environment, i.e. the merchant. And then finally, the PCI audit requirements, the ability to generate audits to say this is when this point of sale was used, these are the users that logged on, these are the transactions at the time the user was at the point of sale. And you have to generate this information on a regular basis anytime you want to claim compliance. Now, the important point to remember is that version 3.0 has some enhancements to all of this, and it's putting the industry into a tizzy because there are probably 100 different controls that have been added to PCI version 3.0, so many people are panicking. Stop the panic because most of them are just clarification of the existing controls. But be aware of the fact that most of the enhancements, this person is nodding, he must know the PCI DSS standard, is all around enhancements and validation of the network segmentation. Because most of the penetrations that have happened have been in faulty segmentation theory. And the reason why is because the complexity of the environments, people miss holes. When you're separating environments with firewalls and blacklists, it's very easy for a hole to develop over the course of time. The theory that we have is that when we look at this, the CDE not only holds the processes and the technology, but the people. And version 3.0 emphasizes the people. You have to track where they're going. You also have to validate and prove where cardholder data exists within the CDE environment. This means that you have to have trace processes and systems, and you have to have flow diagrams showing how cardholder data moves through your environment. The more complex the technology mix, the more difficult it is for you to prove. The value that we bring to the table is that because we have to develop and have hack attack methodologies and ongoing evaluations of threats and vulnerabilities, and to prove that at any point in time, the more penetration or the more technology we bring into the environment, the more difficult it is to have the right kind of pen testing when the analysts come in to say, hey, prove your compliance. What our point is that we can significantly reduce the ACL requirements and enhance the data flow validation because we're using one technology end-to-end. One technology end-to-end, which is shortest path bridging of Avaya Fabric Connect. We don't have MPLS, we don't have BGP, we don't have VRF peering, we're not using a provider. All of this can be piped end-to-end and the customer can own the environment. And then we nail it down with authentication and authorization into the environment with identity engines, realizing that that composite instance has to be recognized and audited. And then finally, as Paul pointed out very eloquently, the management applications. Finally, PCI DSS has recognized the fact that if you can log into the switches and change configurations, then it's not closed. Consequently, we use stealth networking to actually close the management environment so that and any changes to that environment are audited as well. And this gives good clarification, the ability for someone to prove compliance with a much reduced cost. This is an example of the concept. PCI DSS talks about the concept of templating and sampling. So imagine you have a retail outfit that has 400, 500 remote sales sites. Rather than having an analyst come in and scan each and every point of sale location for compliance, they can generate a template. And if they can prove that the point of sale locations comply to those templates and they can generate the topology diagrams and the switch configurations to show that compliance, they can gain what's called a proxy equivalence. So what happens is the analyst will go in and scan a type for each point of sale location, let's say small, medium, and large, and then you prove that the rest of your 300 to 400 locations comply to those, and you will check off and reduce the cost for gaining compliance. Now, stealth networking is used in quite a few other types of technologies. If you visit my blog site, which is shown up on the page here, I have to get my advertisement in myself. I talk about several uses of stealth technologies, particularly in transit authorities and power grids. So do feel free to take time to go up and look at the articles. We also have a very detailed article that we wrote for Multicast as well. It's a little bit older though, you have to go back into the archives. Okay, so with that, if there are no questions, what we're going to do is show you how to set up a L3 VSN extension very quick.
I have a comment, not
Yes.
so much a question. I'm compelled to say that this is impressive. As someone who's been sort of peripherally a security guy for a long time, the fact that, and I've worked on SCADA systems, I've worked on PCI compliance. I've worked on all of these things, and they're generally no fun, right? Especially the PCI 2 stuff that is so highly interpretable that you go to 10 different locations and their PCI folks have interpreted it 10 different ways.
Absolutely.
Yeah.
But I guess I do have a question. So in a former life, I did some work for the Department of Justice and the FBI in particular, and they have this nationwide air gap network. Basically, it's a circuit switched, privately built, completely air gap network, stealth network, just like you're talking about for their private communication. I'm wondering if you can share, if you do you have any experience with building this kind of thing out on a large, say, nationwide scale?
Absolutely.
Yes.
Are you going to disappear?
We can't talk about any.
My clearance is long expired.
In this forum, we can't. Yes, the answer is yes. And the answer is also that, interestingly enough, the verticals that have really taken off on this are state and local governments, transit authorities, also
Stock
casinos.
exchanges. Stock exchanges.
And then
networks.
also hospitals. Hospitals are a very, very major component.
The thing you can realize too
where
about
you
hospitals.
have these complex compliance models that have to be
Absolutely.
met because there's PII flying all over
Absolutely.
the place.
Exactly. The hospital network is actually kind of a funny one because you can't just think about a hospital, what I was talking about before, as being a single building you see on the side of the street. They're actually, for example, the one I was talking about, something like 15 hospital campuses, hundreds of clinics, and they got to provide the same level of security at the clinic that they do in the doctor's office in one of the hospitals.
Across 5 states.
All of that, yeah.
Where this is particularly compelling is, and I harp on this, and these guys are probably sick of me saying it, but in like a university campus environment where you're a research facility, you probably have a medical school, you have a law school, you have PCI compliance needs.
Guess one of our largest customers is universities.
Yeah. Okay.
But you've still got to type Control Y.
What's that?
You've still got to type Control Y. Dead to me.
You got to bring that command.
We have a GUI. Don't worry, we have a
No,
GUI.
just the Control Y. Everything's fine. The Control Y.
So, 2
Dead to me.
seconds on this issue. You guys brought up 2 types of stealth networks. You brought up an L2, and in the L2, let's focus specifically on that one. You effectively said it's an un-IP'd VLAN.
Correct.
So a lot of us have accomplished this stealth network in that way for a long time in enterprises or in campuses where we've had trunking to get it. It gets more complex when you have, routed and you're not doing trunk routed, stuff like that. Structurally,
With
what's-
one exception, if I can stop.
Yeah,
for
that's
one
what I
second.
want to know. What structure?
End-to-end VLAN, you're right. No, you non-IP address a VLAN, but the construct across the VLAN communicating across that core is based on flooding.
Yeah.
Okay, flooding. And if you look at CERT, many of the pinholes that have been developed to get into VLAN environments is based on that flooding.
Exactly. Yeah.
Now with SPB, because the ISIC controls and connects the VLANs together, we're dealing with a stateful deterministic replication capability at each tandem point within the tree.
So there's no flooding of that.
There
There is no flooding. It's,
That's the difference.
the funny thing about this is we actually say there's optimized ARP. You don't ever have to worry about a printer out there killing your network ever again.
Correct.
Right?
Go ahead.
No, just a comment. So we're accomplishing a lot of that same functionality with other stuff, OpenFlow and how Unicast VXLAN works with controllers and stuff like that. And I'm really glad that you guys kicked this entire thing off with the comment on simplicity, because that's what simplicity is.
Yeah.
You're doing all of those functions that we've kludged together with other features with one little thing.
So a lot of customers out there, quite honestly, they're doing a lot of things that are promised in the future by a lot of other protocols today. So they're not worried about, why do I need to wait to do that in a long time? Everything we're talking about, like VM mobility between data centers, we've had data centers, multiple data centers deployed that act like one for over 2 years. Right? Every VM and every environment of that thing all thinks they're connected to one virtual switch router.
Many customers start out with Data Center Connect for Fabric Connect.
Well,
before
and
they
what's really
start
cool about
deploying.
this, there's been a Twitter conversation going on that if you can take and create the simplicity at the base layer, you can take away complexity at
Exactly.
the overlay layers and at
Exactly.
these other layers and spend more time doing cool shit.
Exactly. Get
Exactly.
you away from the console.
Can I make an observation too on it? What are we doing in a wireless world? We're trying to get away from the tunnels. We're trying to remove the complexity, right? So that's an important kind of observation to think. In the data center, should we really be thinking about adding even more complexity and more tunnels? All right?
Thank you, Paul.
Yep, good, sorry.
So what I want to talk about really quick is the fact that we already have a VRF associated on here. And as you can see, we have 2 VRFs shown. we have the global router in vMotion. Note how in vMotion we have no BGP, there's no RIP, there's no SPF, so there's no IGP, no BGP protocol in order to support that. It's all over ISIS. Note how we have a series of subnets that are shown within that VRF. Now what we're going to do is we're going to create a secondary VRF, and that secondary VRF we're going to label as Dark Horse, which is a little personal name that I have for Stealth Networks. As a matter of fact, if you look at my blog, I use the term Dark Horse Networking, marketing preferred stealth. So I don't have a marketing degree, what can I say? So what we're going to do is we're going to create a VRF, and Darren just created it. Now he's just going to go in and we have a VLAN that already exists. He's going to take that VLAN and associate it to Dark Horse. And now he's going to go in and give an IP address to the interface of that VRF for that VLAN. Now he's going back into the VRF module, and he's going to type out IPVPN. This is typically where you get it set up to be set up with BGP and peering and everything else to go into a VRF MPLS environment. We replace everything with one command, the ISID.
No route target, no route distinguisher, no import policy, no export policy.
Nothing. None of that garbage.
Right. Redisputing the routes.
Nope. You missed the K.
Okay, you gotta spell it right. But
There you go. Okay, he just replaced probably around 200 command lines.
On the environment.
Typical VRF configuration with
the
all
thing-
the peering and everything else.
The thing I want to point out here, so now you're looking at, now we have 3 VRFs. Now you have 2 VRFs sitting here, right? So we got the global routing table, we got 2 VRFs in here, but notice no SPF, no BGP, no PIM required for that. All the multicast enabled, all the VRF functionality. Can you pull up the routing table too?
which one do you want?
Just to
Show
show up
both
your-
of them.
Show up your, yeah, show the 2 VRFs, let's go. Dark Horse, and do the same thing for the other one. Actually, can you extend the screen out so it's a little clearer to read?
Let me execute that again so you guys get a better output of that. Give this command.
Okay, so I want you to notice as you're looking at the route table, here's the destination, the mask. The next hop is actually a node announcing that route across the network.
That's the terminus.
Go ahead and hit it. Remotion. Okay, so this is the second VRF, and notice that you have overlapping routes between them.
Totally separate IP spaces, private IP networks.
And again, you're seeing where the routes are coming from, right? So 1018 coming from Singapore, 1018 coming from Singapore over there. We can know where the next hop is going in this environment very, very fast in this kind of perspective, right? So troubleshooting is really, really cool.
So you guys just showed the routing table. You had no SPF. You had done all that stuff. That's what we expected kind of when we saw this. Coming into like insurance and probably hospitals, places that have mainframes, who
Yep.
have requirements for legacy systems to peer into the environment with OSPF or something.
Absolutely.
Absolutely.
You can run OSPF with this and redistribute routes from OSPF.
Okay.
It's IP and Ethernet. It's everything you know about
Run
routing
OSPF
protocols.
directly over it.
Yep. Both models work. So the idea is you can sip or gulp. You can choose to run SPB underneath OSPF and PIM and all that if you want, just as a layer 2 protocol.
I was
Or you
just
could
gonna say,
choose
we've even run PIM over
to
it.
run SPB as your integrated
Why?
one protocol for everything. Now, I'll tell you, almost every single deployment I know of that we have doesn't bother with OSPF and PIM anymore. Why? Right? Why would you keep configuring all these things and fighting with state when you just run one protocol and conversion at that kind of speed?
Correct.
Right?
Is VLAN 32 taken for this VRF now?
Yeah, VLAN 32 is basically what we're using those ports that are assigned to that VRF.
So if I was doing a tagged handoff to customers, 32 is used.
Yeah, there's actually a feature we call transparent uni, switched uni, right? So transparent uni, for example, says I take everything that's coming out of that port, no matter what it is, all right? And for example, the Olympics, there's a blank port, do whatever VLAN you want, and we're gonna dump it out somewhere else, all right? Then there's switched uni, where we can take 4,000 VLANs across every single port to 16 million ISIDs. So we can have VLAN 1 coming to ISID 20 on port 1, and VLAN 1 coming to ISID 22, VLAN 1 come to ISID 23, and just keep reusing the same VLAN across the box, because the VLAN's only port significant at that point.
That's what I was
Alternately,
getting
you
at.
can also have VLAN ID 100 on one side, have an ISID, and then translate it to a different terminus VID that you can port out. So I can go VLAN 100 across to ISID 1000 to VLAN 400 on the other side.
So same customer sees the same subnet with two different
Exactly.
tags.
But only the VID you want them to see. Right.